Okay, so your warm up for I like this quote for today. You don't have to see the whole staircase, just take the first step. Nice. Okay. So today we're going to talk about computing derivatives of the inverse functions. Okay. And so there's a little bit of an activity we're going to do. It talks about your partner. What I want you to do is just at your table to pick one match. Doesn't matter which one, you're all going to use it. You can stack all the others together. All right, so it doesn't matter. You can choose which one you want to use as your one match. Okay, so just choose one, then put all the others aside. Okay, so choose your one you want to use in this activity. Okay. All right, so here's what I want you to do. All right, so it talks a lot about inverses because we're talking about how do we compute the derivative of an inverse. What's that relationship there? And we'll build off of this tomorrow. So this has, I think, 5 questions, all right, that it asks you to answer. And you're going to be using those graph cards to help you do it, okay? So if you would, go ahead with your one match that you have at your table that you like. You're like, confident in this one, all right? I want you to take that one. I want you to answer those 5 questions, work together, and walk through that, okay? Go.
How can you tell?
Which card?
Just pick one.
Oh,
I'm assuming
Just sketch one. It doesn't matter. Of your one match that you have, just sketch one.
I miscounted.
You have points on that.
Yeah.
And you missed.
I made them. There we go.
The one
They're ready to out.
fill the table where you did it.
Oh.
Give to one. There's 1, 2, 3.
Yeah.
So simple.
I went in doubt. Just.
Oh, yeah.
Yeah.
One that put down the one that's actually right.
I made them.
Do you want those are
So they're not the order pairs, those are the X and the derivative.
those are the inverses of the order pairs.
sorry.
So what you gotta look at the points.
Well, the graph is over the derivative. So those are, but you put the order pair.
Well, this little table says that
I almost put negative on.
18 1 8 plus
That's one there. Okay, how do you find the number?
That's the derivative.
How do you find the fourth order pair?
Fourth order pair.
Divide by 2.
Invert one of these points.
Sorry, I saw.
Divide by 2.
What's the point from?
Because it'll be like the one you're using. Divide by 2.
3, 1.
You only went so much
No.
vertical line.
6, 2.
No.
No.
Two or no?
The 2 knows the graph. The 2 will divide. Just think about it.
My guess is just to look at the graph and see what. We're not stealing, we're just borrowing.
I honestly don't see them.
No, there's the inverse, yeah, because the graphs are.
So. Makes sense. First derivative.
How can you find your scrap?
For this? Yeah, no.
No, it could just be that.
This is not the derivative. This is different. This is
Oh, that's the graph, that's, oh, wow.
yeah, that's what I told you. Guys, I told you this. Guys, listen to me.
Say no, it's a little something.
Yo, listen to me.
Sam, why would they listen to cable? What are you saying they're listening to?
It's because it's brown.
Now you didn't do it?
You can ignore that.
I know, just to get through.
I mean, I just asked if they like go down there. She was like, yeah. They're pom Yeah, they're okay. Surely the coach is okay. Yeah, you should just show them the standards. I mean, it's all big.
I saw it in
I was
my.
gonna say, why were you doing that?
Because I wasn't at the game.
So why weren't you with the senior night? Come on.
Not at night.
Thank you, partner.
Did we win?
No.
Yeah.
We did not.
So,
I was hyping them up to get
You were there?
Yeah, I was cheerleading.
You're cheerleading, why?
I asked Miss Payne, she was like, yes.
I could have pulled
They had spare pom pom in there.
You were with the girls?
Nah, I wasn't with the girls.
There was
It was a sight to see.
You think I'd be able to see you walk that far down, but I didn't.
You didn't? Oh,
What's your number 4, guys?
well, I was there like,
Is your number 4?
A while. We were there.
yeah. I
It was
scrapped.
like
No, I
all
know
of
that's
Yeah, it was all for one more. I
Probably
think
from
it
the
was
second quarter.
I think it was second because I remember going back to the stands.
All right.
During half.
We must be close to done.
Don't tell me
I
that.
see phones.
Yes, we're,
Okay, but
we're using calculators, like,
That's not your function.
but I don't know.
Eat
You have to show off.
inverse.
Because none of them know the word.
Build a table with 3 words for derivative.
Greenway is
We know, you didn't tell us.
Yeah, we just have to yell at it every time.
Well, no. Everyone around you yells it. They're a lot louder than you.
But they're wrong.
But they're like in my earballs.
My husband is officially a bus driver. He passed his test this weekend.
But they're in my earballs.
Did you run a thing?
You're not in my earballs.
I did. I didn't run. I walked, but it was good. I was third from last. It's okay. I was third from last, but I wasn't last. I did it, and I was not last in my age group, so that was good. Yeah, and I wasn't sore when it was over. I didn't need my inhaler, so progress. Yeah, progress.
I think it's not too late.
Yeah, it is a little too strong.
Let's take about 2 more minutes.
It's too strong for me to change it, bro.
We got 2 more minutes to walk. We got that.
What's the 4th?
Building table.
Let's grab this 3. Yeah. 11. X equals 11 when I graph it out.
All right.
I mean, yours is.
Yeah. So I feel like 3 words Oh, the top of our table. Okay, who's your purpose?
Do you have arcade?
You need to pay to have Apple Arcade.
Yes.
It's a monthly subscription.
We're about to drop our Disney Plus subscription just because it doubled in price. Yeah. Or we tell Becca to split it with us. All right, so let's kind of walk through this together. All right, how could we tell that we had inverse graphs? What was it that clued us in that they were actually inverses? What is it we had to look for? Yeah, the x and the y values had switched. And that's the basic definition of an inverse. You could have also said it was a reflection over the line y equals x. All right, that's why it's true. All right, so all the things that we learned back in pre-cal. Okay, so the x and the y values were switched. So I chose this graph. It's a cubic that has these points. And I filled in my 3 ordered pairs. Now, how could we get that additional ordered pair off of the matching graph? Okay, so I go to the inverse graph. And mine had the point 9,2. So what point would be on my function? So 2, 9 would be on the function. Okay, so this is all still just definition of an inverse. Okay, no calculus right there. All right, so if we want to find ordered pairs and I have an inverse, I could take its ordered pairs and switch them. It would give me its corresponding ordered pairs on the alternate function. Okay, so this time it asked me to look at the tables, okay, between my 2 functions, my original function and my inverse function, and then to compare the slopes. What's represented by the slope? Or how do we represent the slope in that table? The derivative, right? So the derivative equals the slope. All right, so f prime equals slope. Okay, so let's look at our tables that we've got here. Okay, I like to go ahead and kind of fill in my derivative table first before I answer number 4. So I have -1, 3, 0, 0, and 1, 3. Okay, so what that's saying is if I go over here to my original graph, the slope at -1 would be 3. The slope at 0 would be 0. The slope at 1 would be 3. So this is my slope of my tangent. So let me just sketch those in on my graph so you can see it. Okay, so it tells me at the point 1, it would be, well, it helps if I can write. It helps if my pen's on. All right, it would have a slope of +3. At 0, it would be 0, and then here it would be +3. Okay, so that's what it's telling me is the slopes of my tangents at those points will be represented that way. Okay, it asked me to look at the inverse functions slopes as well. So I'm going to actually draw that chart right here. Okay, I think it'll just help you to see it. And I'm going to write this as, notice this notation, f inverse prime of x. Okay, so because what I have here in that table is the inverse. So at 0, I have 1/3. At 1, it is undefined. And at 9, it is 1/12. Okay. Do I have the wrong graph? I don't think so. -1 is 0, is be 0, -1, 0, 1, be 1, 0. Yep, I got the right graph. Okay, so let's just take a second and kind of look at these values, see if there's anything we notice. Make sure I got the right graph sitting right here. Yeah. Okay. Do you notice anything? There are a lot of threes. I would concur. It's crickets. Y'all don't see anything. Look at your tables. I'm seeing some motions. What are you doing over there, Himmel? What are you thinking? Yeah, I'm thinking reciprocal as well. Okay, but let's talk about why the values are what they are. Okay. Notice the x values between that function, okay, and your inverse function. Okay. Do they match? Okay, think about your ordered pairs over here. Let's go back, look at them. Okay, so there are your x values for f of x along with your y values. Okay, so -1, 0, 0, 1, 1, 2, 2, 9. Okay. Are there some tables that are easier to see it in? Possibly. In terms of your derivatives. Okay, so Himmel's thought is that at inverse points, the slopes are reciprocals. Well, let's talk about why that's true. Okay, he's right. All right, so let's talk about why it's true. On the original graph, so on f of x, my ordered pair was what? -1, 3? Oh, that was my inverse. My original ordered pair was -1, 0. Okay, so then the ordered pair on my inverse function would have been 0, -1. Do y'all agree that on the original function and its inverse, that's the correct ordered pair? Okay. So now let's take a look here. When I look at the derivative at -1, I get +3. Okay. But then notice what happens. In the inverse function, they do the derivative at 0. Why do you think they choose the derivative at 0? negative 1 zeros on my function, why would in my inverse function they choose the derivative at 0 instead of at negative 1? It's okay to guess out loud and be wrong.
They're related inversely.
They are related inversely.
Booyah.
Yes, okay. The y of the original function is the x of the inverse. We know that. They switched x and y. So that's why these match. And so now if we look, it's easier to see, okay, that that's what we have there. I refer to these as, what did I call them last year? I can't remember. I called them some weird name and it helped us to remember. I don't know. All right, but they're just inverse points. I think I refer to them as a match point. Ooh. Okay, I refer to them as a match point. The x values can't be the same because they're on inverse graphs. Okay, so the x's and y's have to change. So what is the x in my original? Is the y in my, is the x, no. What is the y in my original is the x in my inverse. They are inverse points. They match inversely. Okay, and so when I can do that, I can see that their derivatives are reciprocals of each other. Okay, the derivative at negative 1 was positive 3. The derivative at its match point, its inverse point, x being 0, is 1/3. Okay, and so that's one of the things we have to remember, and that really is the definition for inverse functions. Okay. So let's say that we had something like this. Okay, let me just give you an example and let's see if we can walk through it. Okay, so I've got f of x and it has the ordered pair 2, 4. What's going to be my inverse point on f inverse? 4, 2. Okay, and so if I know f prime, or the slope at 2, is negative 2/3. Okay, let's think about what my f inverse prime slope is going to be. What would my x coordinate be, okay, for that inverse point? So this is the tricky part. What would my x value be? 4, okay, because it's got to match this point, so it's got to be 4, all right? And then its slope is a reciprocal, so what's its slope going to be? Negative 3/2, okay? It's not an opposite reciprocal, it's just a reciprocal, okay? So the key here is finding those inverse match points, okay? The x value on my original function is 2. That means the x value on my inverse that matches it is 4. Okay, because it has to be the y from that original function, all right? If I know the slope at that match point is negative 2/3 on the original function, it's going to be negative 3/2 on the inverse. It's going to be the reciprocal. Okay, so let's do a little mathematics here. What do we know happens? So let's say f and g are inverses. Okay, what's true about their composition? If two functions are inverses and we compose them, what do we know it equals always? X. Okay, so let's do a derivative. Okay, how do we do the derivative of a composition? Yeah, we do that chain rule thing. F prime of g of x times g prime at x. What would be the derivative of x? 1. Okay, if I want to solve for g prime at x, what would I have to do? Divide. So g prime at x is equal to 1 over f prime at g of x. Now, that's the formal definition for derivative of an inverse. Okay, I never use it. Okay, just so you know, I never use it because I just don't have space in my brain for one more definition. All right, we have so many that we have to do. Okay, but that is the formal definition for derivative of an inverse. Right? Okay, that is the formal definition. If f and g are inverses, then the derivative of the inverse g is the 1 over. That's where we get that whole reciprocal, okay, thing. But here's how I remember it, okay? Here's how I remember it. If f and g are inverses, their ordered pairs are switched. Okay, so that's the first thing I remember. If f and g are inverses, their ordered pairs switch. All right. So I've got a and b on f of x. On g of x, I've got b and a. Okay. So then, f prime at A and G prime at B are reciprocals. Okay, that's the definition that I remember. Right? And I think once we've done a few, it's easier to see. Okay. What?
It was just Garrett.
Gareth and his switchblade comb over there. Okay.
Did you color your hair with that, bro?
Okay, so let's do some practice. All right, because these are a little bit weird. Okay. There you go. All right. So several years ago, my students really struggled with these, and I got a little bit better at teaching it. You may not feel that way right now, but that's okay. And we never miss these on the AP exam anymore. Okay, we always get 100% on these questions, and it's going to happen again. Okay. All right. So let's just take a look. I draw a lot of tables. It helps me. Okay, it helps me. So let's take a look. It says, let f be a differentiable function such that f at 5 is equal to 20 and f at 7 is equal to 5. So they've given me f. Okay, they've given me two ordered pairs, and I'm going to write it down. F at 5 is 20, f at 7 is 5. Okay, it also tells me that f prime at 7, so I'm going to draw a separate table, f prime at 7 is negative 5 over 2. Okay, so I'm just taking the information that they've given me and I'm jotting it down. Okay, the next thing it tells me is that g is differentiable and that g is equal to f inverse. Okay, so they are inverses. So now that I know f, can I get a table for g? Yes. Okay, so what would that table be? 20 and 5. 5 and 7, okay? All right, so it's asking me about g prime at 5. Why did they ask me about g prime at 5? Yeah, because those are those inverse match points, okay? 7, 5 matches 5, 7. They're inverses, all right? So if the derivative at 7 is negative 5 over 2 on f, what does the derivative at g have to be at 5? Negative 2 over 5. It's just a reciprocal. Okay, that's what it's asking me. Okay. Digest that for a second. We're going to do another one. Can you formulate a question? Or are you just staring absently at the board, praying it clicks at one point?
Yes.
Yes, it's all right. It's allowed. Sometimes it takes that. Okay, let's do another one. All right, let's do another one. The tables help me. It may not help you, but it helps me. All right, let's look at this one. So this time it goes a little more in depth. It says that the function h is given by, and it gives me an equation. Okay, so h of x, I actually know an equation this time. H of x equals x to the fifth plus 3x minus 2. Now, if they give me a simple function, I could probably calculate an inverse. But are you going to be able to calculate an inverse of that? Yeah, no, me neither. Okay? So here's what we're going to do. We're going to take the next piece of information they give me, and they tell me that h of x, so h at 1 is equal to 2. So when I think of h inverse, what point is it going to be? 2, 1. Okay? Good to know. Right? It wants me to find the value of h inverse prime. So h inverse prime at 2. Okay, that's what it wants me to find. Well, I've got to kind of back my way into that because I'm going to need to know h prime first. But what x value do I need to find h prime at? One. Okay, at 1. All right, I have to find h prime at 1 because their two slopes will be reciprocals of each other. Okay, well, if I have h, can I actually find a function for h prime? Sure, let's do it. Okay, so h prime is going to equal 5x to the fourth plus 3. The x value I'm using is 1. So that gives me 5 times 1 to the fourth plus 3, or what would that be? 8. Okay. So if the derivative at 1 is 8, what's going to be the derivative of the inverse at 2? 1 over 8. It's the reciprocal. Okay. Once you get to the derivatives, they are reciprocals. And that's what I'm looking for. Okay, it just takes a minute to kind of fool with it. Okay. Let's do another one. Okay. It's all about the information that they give me. Okay, so let's walk through it. They give me a function for f. I'm probably going to need it. Okay, more than likely I'm going to take a derivative of it at some point. Okay, they tell me that g of x is f inverse. That's good to know. Okay, and then they tell me that the point on g is 2, 1. What does that mean the point on f is going to be? 1, 2, good. Okay. It wants me to find the value of g prime. Okay. At 2. Well, it's got to match or be an inverse to what value on f prime? What x value? Okay, there's my match point. Okay. So what does the x value have to be on f prime if the x value on g prime is 2? 1. Okay. So it has to match the f table, it has to match the g table. That's how I line them up and seal. Okay, if it's 2 on g, then it's 1 on f. All right. So can I find the derivative of f at 1? I hope so. If not, I've done a bad job. Okay. So, oh, sorry, that should just be f. If f of x, so f prime at x is going to be 3x squared plus 1. We're going to evaluate that at 1. So f prime at 1, 3 times 1, Gareth. All right, 3 plus 1, which would be 4, right? But it wants g prime at 2. What do I do to that derivative I just found? Reciprocal. Okay, and the reciprocal of 4 is 1/4, and that's my answer. It's all a reciprocal. Okay. Let's do a table. Right. Same process, so it gives me a table to start. All right, and it tells me that F inverse is defined. Okay, so I'm going to make me an F inverse table for just a second. Okay, so I have 0, 49. My inverse would be 49, 0. On X, I have 1, 2. On F inverse, I'd have 2, 1. Right? On F, I have 2, negative 1. Whoops. So on F inverse, I'd have negative 1, 2. Does that make sense? Okay. So now let's talk about F inverse prime. Okay, I want F inverse prime at 2. Okay, so which X value are we going to look at on F? We're going to look at okay, if F inverse is 2, 1, F is 1, 2. Okay, so that's the point I'm looking at. You switch them. Okay, if F inverse is 2, 1, okay, then I switch them and I look at 1, 2. Well, what's my derivative of F right there? Negative 8. So what's it going to be on my inverse? Negative 1/8. All right, let's do one more. And then I'm going to let you go. Okay. So it says, find the equation of the tangent line to the inverse of f of x equals all of that at the point -4, 0. Okay, so at the point -4, 0. So interesting things happening right there. Okay. So, what is the point on my inverse function? Okay. So, f inverse of x, we have -4, 0. So, what's going to be the ordered pair on f? 0, -4. Okay, so that's important to know. The only function I have is f of x. Okay, so I have to start with its derivative. Okay, I don't have the inverse function. So f of x, all right, is x to the 5th plus 2x cubed plus x minus 4. F prime at x would then be 5x to the 4th plus 6x squared plus 1. What value are we going to evaluate it at? 0. Okay, we're going to evaluate it at 0. So f prime at 0 is going to be 1. I'll plug a bunch of stuff in. Okay. So then what is going to be the slope of f inverse at -4? F inverse of x prime is going to be the reciprocal of 1, which is still just what? 1. Okay, so because we're writing the equation of the tangent line to the inverse, we're going to use the inverse derivative and the inverse point. Okay, so my tangent to the inverse is going to be y equals 1 times x minus 4 plus 0, or x minus 4. I mean plus 4, sorry. Minus a negative 4, so it'll be plus. Right? So you got to really pay attention to what it's asking you for in terms of which function you're going to look at. Okay? All right. So I printed you off some problems that are from AP Classroom. They're strictly about this. They are multiple choice. You need to try them. Okay? Because it gets confusing when all the junk gets in there. Okay? So your lesson practice is that worksheet. All right, derivatives of inverses, and your wrap-up's open. Okay. Be sure you do that. I'll try to remind you in the morning, too, in case you forget, since it's almost time to go. Okay. But there you go. Tomorrow we're going to do 3-4. Talk specifically about the inverse trig functions. They have formulas, which is nice. And then we'll talk about higher order derivatives on Wednesday. Second derivatives, third derivatives, et cetera, et cetera. Yep, that's the plan. Okay? All right, good job, good job. This test is a little bit harder because there's just lots of places to make mistakes. Bye, y'all. Be good.